Okay, today we're going to talk about relations and functions, and we're going to introduce something called function notation. Okay, a relation is just any set of ordered pairs. Now that relation can be given to you as just what it says, a set of ordered pairs. That could also be given to you in the form of a table. It could be given to you in the form of something called a mapping, which I'll give you an example of in a little bit. It could also be given to you in the form of a graph. So a relation is just any set of ordered pairs. A function means that and some relations are called functions. And what it means is that for every input, there's exactly one output. But again, not all relations are functions. Okay, there's something that's called the vertical line test that you can use to determine whether or not a relation is a function. Okay, this would be something you would use if your relation was given to you in the form of a graph. And the vertical line test just says that a relation is a function if and only if no vertical line passes through two or more points on the graph. And so what that means is that in a relation, every x value can only be used once. You can't have 5, 2 and also 5, 3 because then you end up with an input that's paired with two outputs. And so that's not a function. On the next page, I'm going to go through a few examples of how to use the vertical line test to determine whether the graph of a relation is modeling a function. Okay, so here are 4 graphs, and over on the side here I have a little green line which I'm going to use to do the vertical line test. Right? All we're going to do is grab the line and take it across. And as you go across here like this, you can see that nowhere is that green line going to intersect at more than one point. Okay, the graph is the red line. So, do the following graphs represent y as a function of s? This first one, the correct answer is yes. Okay, it does represent a function. On example 2, if I bring this green line over here, and you can see starting pretty much right there and going everywhere as we go across, right, there are plenty of places where there's 2 points. And what that means, right, these 2 points each have the same x coordinate. If you look at this is approximately 2, -3, close to, and this one is close to 2, 3. So there's 2 points that the x coordinate is the same. Right? They're lined up above each other. So that means that this particular one is not a function. So is y a function of x? The answer there would be no. And if I grab my line and bring it down here, on this one, as we go through, you can see nowhere is it going to intersect the red graph more than one point. So this one, y is a function of x. And then example number 4. Maybe try and fix this here. There we go. Now I'll take my line across. And nowhere is that going to cross at more than one point. So is this one a function, y a function of x? The answer is yes. So we had, in this case, we had 3 of them that were functions, number 1, number 3, and number 4, and one of them that was not a function, number 2. Okay, on this page, it says decide whether each relation is a function. It does say that each relation is an example of something that's called a mapping. All right, well, in a mapping, basically, the left side, this is kind of like your x, and this is sort of your y. Right? And so this first relation has 4 ordered pairs, and those ordered pairs would be -3, -8, 0, -8, 2, 1, and 5, 7. So the mapping is representing 4 different ordered pairs. Right? If you look at the x coordinates for each, they're all different. Right? The y coordinate doesn't matter. So this particular one is a function. For example, 2, right? This one, the ordered pairs are -4 and 5, -4, 8, and 9, 12. And you can see that I have 2 ordered pairs that have the same input. So this one is not a function, because for each input I can only have one output. So they're relations. They both are relations, but number 1 is a function, number 2 is not a function. A simple way to look at a mapping and determine whether or not it's a function is go to each input value and see how many arrows are coming out of it. Okay? I have 4 inputs and 4 separate arrows, 1 arrow from each. That means that it will be a function. In number 2, I have 2 input values, right, but the -4 has 2 arrows coming out of it, so that means there are going to be one input that has 2 separate outputs, and that's why that is not a function. All right, now, the next thing we're going to do is start to introduce function notation. And first I'm going to go back and review something that everybody should be able to do. Okay, find the value of y when x is 3. So if I have y equals 2x plus 7, okay, if we say that x is going to be 3, basically what we do is plug this number in right there, and then just evaluate. So y is going to be 6 plus 7, y is going to be equal to 13. And so then y equals 13 when x is equal to 3. And this is something we did at the beginning of the year, and everybody should be able to do that. Now, function notation, and we're going to introduce a slightly different notation, but it's going to be the same thing. So we have function notation says that in general, this f with the x inside parentheses beside it replaces y, and it's read as, and I put quotations around, the value of f at x, or a little simpler, f of x, and that's probably more typical what you would hear, f of x. So the original equation was y equals 2x plus 7. We are replacing the y with f of x, and so it's f of x equals 2x plus 7. And this is what's called function notation, and this is something that you're going to see a lot in high school. Okay, they're not really going to use the y a lot. They're going to be a lot of f of x's, g of x's, h of x's, and so on and so forth. And so the way the question is going to look is they're going to give you the function like this, right, and then this would be the question. Find f of 3. And so what we would do is f of 3, notice I'm put the 3 got put where x is, so on the right side of the equation what we do is we put 3 where x was, and we just keep going. F of 3 is equal to 6 plus 7, and f of 3 is equal to 13. Now that does not say f times 3, so do not divide by 3 and get that f is equal to 4 1/3. Okay, we're finding the value of this function f. Okay, we're finding the value of this function f. Okay, and the function is 2x plus 7. Function f is. Okay, and we're finding the value of that function f when x is 3. And that just means you put 3 in where x is and do the math. And when you do that, you get 13. The same as we did when we put 3 in for x and the y equals 2x plus 7. And I have 2 examples here. Okay, the first one, it says that the function f is 3/4 x minus 4 when x is 8. Basically what you're going to do is you're going to take this number right here, you're going to put it right there in place of x, and you're going to do the math. So f of 8 becomes 3/4 times 8 minus 4. And so f of 8 is equal to 3/4 of 8 is 6, 6 minus 4, so then f of 8 is equal to 2. And that's your answer. On the second one, we do the same thing. X is 3, we plug it in right there, and we figure out what f of 3 does. In this case, we're going to do 2/5 times 3 plus 7. And 2/5 times 3 is 6/5, or 1 1/5, plus 7. And so f of 3 is equal to 8 1/5. So what you should be able to do is look at any type of a relation, whether it's in the form of ordered pairs, table, graph, even an equation, okay, and mapping, and you should be able to determine whether or not that relation is a function. You should also be able to recognize function notation, what it looks like, and then evaluate function notation given values of f, or values of x.